DQ Z4.
It's what? Dairy Queen Zebra 4.
Yeah.
Come on.
What's the alphanumeric? Like the thing they use in the army? What's Q?
Quebec.
Y'all watch Archer?
Yeah.
He's like trying to say N or M. He's like M for Mancy. What'd you think I said? What'd you think I said? All right. Object-oriented 1.
I used to work for an investment company, and like, there's a lot of like little letters that you have to say like that, so everyone knows it all the time. And every once in a while, you come across someone who just forgot one, and they're like, Charlie, Echo, giraffe.
Yeah.
They said this season was up into the last one. I read, they may have changed this. I read it a while ago, so they may have changed it. But I think everyone was like, up to 10 seats there.
All right, so let's do this.
My information sounds inaccurate.
I wonder if it'd be easier if we did it in. No, I guess we'll be okay here. So create a class ship. Class will have properties, name, type, crew, and ability. The crew will be an empty array upon installation. Initialization. Instantiation. Do you know instantiation isn't a word? I use it all the time, but I don't think it's a word. It should be a word because we do it all the time. Okay, the first thing we want us to do is create a class ship. Do I want to do it the old way or the new way? I guess we'll do it the old way. Function capital S ship. It's going to take a few parameters. And I'm going to just name them as instance variables, meaning just the word this in front of it. And crew, we're just going to start out with an empty array. And we should be able to instantiate things, so lowercase m mav, lowercase because it's just an instance of a capital S ship, which is a class. I'm going to pass in a few parameters here. For the name, it's going to be Mars Ascent Vehicle. It's going to be a MAV type vehicle, and it will have the ability to ascend into low orbit. And then I should be able to console.log mav npm run, or no, node 05 travel, nope, 04?
Yeah.
No.
No, it's 05.
05. Am I typing wrong? Oh,
Space
space
travel.
travel Mars. There we go. Yeah, there we go. So it looks good. And I'll do this because it's good practice. Always put the name of the variable in a string. Help you keep up with things. And I'll totally skip over spec 1. Create a class crew member. Okay, let's do that. Function capital C crew member. It takes a name, job, special skill, and a ship. Though the ship will initially be null, so I don't need to pass that in. This is real programming right here. Nice and boring. Just repetitive. I love it. I love it. Helps you solve problems. Same thing, over and over and over, special skill. And this dot ship we said was going to be null, some place saver. Okay, math seems to work. Spec 3, crew member can enter a ship via the method enter ship. A crew member can enter ship via the method enter ship. So sounds like enter ship will be a method on crew member. Method's just a fancy word for a function, right? In fact, there's a lot of discussion on the internet when to use one and when to use another. There's not really a good solid answer of when. I typically say it's a method if it's on an object, right? So if I say dot crew member, I'll call it or dot enter ship open close, I'll just call that a method. But if it's a function off of its own, like how we've been writing them so far, I usually just call those functions, right? That's how I usually distinguish between them.
What the book says.
Is that what the book in here?
Yeah.
Our book? Oh, that's kind of biased though, because I wrote it. But hopefully y'all can find it somewhere else where it mentions it like that. But yeah, so the word method, but they can be used interchangeably, which kind of stinks. So it says that crew member has an enter ship, so this dot enter ship. Oops. Equals, but it is a function after all, so function passing this method, which should be a ship instance. So a ship instance. So if its parameter is going to be a ship instance, would this be correct? No, right? Because capital S, first of all, insinuates that that is a class, right? And a class is not an instance, right? You have instances of classes. But an instance itself is, by definition, not the class. Okay, so if it's a ship instance, typically, conventionally, it would make sense to me to use the same word as the class, right? But to make it lowercase, right? That doesn't make sense. If that doesn't make sense, literally just be, be explicit if you want to be, right? When I first started programming, everything was just so explicit. It just took, I quickly hit my 80 character limit on a line. All right, it's only until later that I realized I didn't have to always do that. So ship. But remember, that's a ship object, right? A ship can have many attributes. It can have a name, it can have a type, it could have a whatever it's supposed to do, the skill or ability or whatever. But the ship itself is that object.
So the thing that always gets me is whatever you pass in could be anything. So ship is not the function ship. It's just whatever.
Yeah, the ship, exactly. I could type in whatever in here. Yeah, it's just semantic for your sake, so you don't go crazy.
So it has nothing to do with this dot ship when you declare it as an argument in function.
Right. That ship passing into the function is just for me to say the first thing I'm going to pass into this function, I'm going to be able to use at this keyword that I'm choosing, at this variable name that I'm choosing. And trust me, that's one of the hardest things to get. And that's the hardest thing that got me. How did I know? How did I know to call that ship?
Class 2 could be like any ship at all, right? So that what you're passing in needs to be a specific thing, right?
It needs to be a ship.
So the class is like too general almost.
The class, yeah, exactly.
Yeah.
It's just like a blueprint for a class. There's not even technically a ship, right? Like,
Right.
It's just an idea. I don't want to pass in an idea of a ship. I want to pass in a literally metal ship with attributes. So passing in the class ship wouldn't help me in this case. I don't want to pass in an idea. I can't enter an idea of a ship. Okay, so it says that this be assigned to the argument passed in this method, which should be a ship instance. We can pass an instance of ship class into inner ship method, and this method should also push the crew member. Oh, sorry. We can pass an instance of ship method, and this method should also push. No, I skipped over it, sorry. By calling enter ship method on crew member instance, the ship property of that instance. So even though I don't have any instances yet, I do have an instance variable called ship, right? And what variable is that?
Ship.
An instance variable. This is the instance variable, right? That's going to be whenever I have an instance, I'll be able to say that instance whatever dot ship, or that attribute. So this dot ship, and that's what it's telling me. It's saying the ship property of that instance. It's out of context, but that instance is talking about the crew member instance. will be assigned to the argument passed into this method, which should be a ship instance. Passing in the ship instance, that ship instance should be assigned to the instance ship variable of this instance.
Using this to throw me off last night.
The use of this?
Yeah.
This is hard and it's weird, definitely, but it's definitely powerful.
Once I realized it was like that, it was when it's necessary, it got a lot easier to
Yeah.
go further on.
Definitely. And this is something that translates in other languages too, right? They actually look weirder in other languages. In Ruby, they're called, it's an at symbol. So I would say at symbol ship.
So
That's weird, right?
That context of this is instead of this, it's essentially saying intership dot ship equals.
It's saying-
Not ship.
Yeah, it's saying that this is referring to the crew member that I'm inside of. Okay, I'm inside of this. I want to assign this dot ship. So this dot ship is the same thing as this dot ship.
Okay.
All right, and this will eventually be replaced by the instance that I'm inside of. It'll just refer to myself. Equals the ship that I'm passing in.
Yeah. It's just strange that this on the other one is referring to the function that it's inside of, but when this is inside of the function, on the second one, it's not referring to the function it's inside of. It's referring to the overall function that it's inside of. You see what I'm saying? Like the scope is
Very confusing.
seems weird.
That is confusing. And it's confusing. The way it's working is whenever you're setting this up for the first time, the scope inside here hasn't been it doesn't have its own little scope yet, and so it just takes the outside scope and it takes the scope and inserts into this, and then builds this function, and then it just sort of like attaches onto it. But you're right, it's weird.
But if I wanted this to equal intership, then is that where the whole bind stuff comes into play? Where you would bind this to intership?
Yeah, so if we were to use like the bind function and stuff, it's gotten a little better. I haven't really used bind in a long time because it's just, you don't really need it that much anymore because of things like this. In fact, before ES6, we had to use, for the reason we use fat arrow functions, this is a great case of why we use fat arrow functions. So it doesn't apply here, which stinks. But fat arrow functions will pass in your this, and it'll pass it in. So how functions always have their own this context, a fat arrow function makes a function not have a this context. It'll just take the outer this context and pass it in. And that's why we have fat arrow functions. That's what I'm saying. Before that, we had to make a variable called that. There's several different ways to do it. But right before a function, you would say var that equals this. And inside the function, you would refer to that as the outer this. How's that, right? Total mind bender. I still do it and it drives other people crazy.
In this intership method, if I just say return this dot ship, if I don't pass any arguments, is it going to just return null because it's set null inside the object?
No, because this will only run when I call the method.
Okay, what if you call the method
Without passing anything in,
yeah.
it'll do undefined.
So either way, I won't get the null value because it's normally set to null. This dot ship.
Yeah, like if I instantiate a crew member, let's do it. If I instantiate a crew member, var Luke equals new crew member. His name's Luke. His job is Jedi. His special skill is lightsaber. And I did console.log Luke. So here's Luke. Special skill, ship is null, as of right now,
Yeah.
right? And then if I just called randomly Luke.enterShip, but without passing anything in, it won't be null anymore, it'll be undefined, right? Which is hard because like they're almost the same thing, but not really. But basically it's just because it's looking for that up there, right? It's looking for that ship, but only then did it call it. But if I were to call it down here after mav was instantiated and I was able to say pass in mav, then I have mav in as the ship then.
But what if you don't declare any argument? Like, if you just say
This
this
right.
dot enter ship, yeah, just no arguments, and then return this dot ship.
It would just return this dot ship.
Is it gonna be undefined, or is it gonna be in this case null?
It would be null.
Okay then.
That's a good question. It'd be null. In that case, it's more of what's called a getter, right? And actually, you do that because say for instance, I wanted to be like this dot. In ES6, you can do them natively. I don't know if there's a special way to do it here. So we can say like get ship. I think this is actually what you used to have to do. You just write the word get in front of it. I told you it was a getter function. And you're like, well, what's the point of a getter? Well, like say for instance, I wanted to say get ship. And I didn't want to actually give like the entire ship object. I really only ever wanted to say ship.name. So Luke.enterShip. So say for instance I said, well, better yet, enter ship. Let's make another function so we can use this. So I'm just putting it back how it was. Let's do a ship getter called a get ship. And I said return this .ship.name. And that way I said Luke.enterShip math, and then I said console.log or Luke.get.
Get that. That's a string.
Yeah. Oh yeah, this isn't going to show up, huh? Console.log. Oh, I'm console.logging it, so that'll work. Okay. Yeah, so now I have a getter called Mars Ascent Vehicle. Even though Luke.ship is something else, I have a getter function that kind of like makes it a little bit more human readable for me. And that's what a getter is. The getter just manipulates it before you get it. Okay, now you can set even more complex ones, which are nice. But we don't have to worry about it right now. Let's not worry about the getters. Getters and setters. You can think of a setter being really valuable though. Think about if you have like a first name, last name. Like most objects have a first name and a last name for a person, right? But say if I were taking input from somebody and they were like, but they wanted to write it as first name space last name and just give me one string, you'd have a setter, set full name that actually took it, split it on an empty space, and then assigned your first name and your last name, right? So setters really just manipulate the information before you set it on the object, and a getter manipulates how it looks before you return it back. Right, so setters and getters are actually really valuable because most likely your class doesn't look like what a human readable person would be expecting. You don't always just be like, hey, whatever .job, right? Like you don't always put it like that. Like a job, may be a culmination of a whole lot of things. Okay, so we have this Luke.enterShip, and when I console.log Luke out, we have Luke.getShip. Okay. So I have a ship. I'm in there. Okay, but it should also do, we can pass an instance of ship. This method should also push the crew member instance. The crew member instance in this case is what variable?
What's that?
The crew member instance would be Luke, right? That's an instance of the class. And remember, in short, an instance is just something where you said new class name. That's how you instantiate the word new. New is just short for a new instance of. You can kind of think of that. This method should also push the crew member instance into the ship's crew array using .push. Okay. So where are we? Right here. So now we need to access the ship that we're passing in, right? Ship. The ship has a crew thing right here, right? That instance, whatever it will be, will have a crew. It's an array, so I should be able to push. And I need to push in the instance, the crew member instance, which at this point is what? This. I'm the instance, right? I am the current instance. And so that's why I'm pushing this in. I don't know, and if I'm thinking on the class level, I don't know what my name is. I don't know any of that. But I do know one day I'll grow up and become an instance, right? I'll be an actual thing. and this is what I am. That's what's going to be pushed into the ship. Okay, the ship that is already a metal completed ship at this point. Now, quick trivia. So right here, I'm passing in ship, and I set this dot ship to ship. Okay, could I have right here said this dot ship? Would that have worked the same way?
No,
I feel like I tried it, but
because the ship down, because this dot ship refers to the ship thing inside crew member. And you're pushing this
Yeah.
over to the thing in the ship.
But I already set it though above it, right?
I think it could work.
Yeah, I think it would work here, right? So here, because I said it, and I've already made this reference, right? Everything in your code are referencing each other. This dot ship actually references where the ship lives in your memory, so that works all right, right? But that's not hard because maybe some of you were like, no, I definitely tried that and it didn't work. Now tell me, what if I would have said, what if I would have put it beforehand? Would this have worked?
no, because you haven't.
Right, because at this point, if this was the first time I did it, this dot ship would be null
Nothing,
still,
yeah.
right? And so I wouldn't be able to say this dot ship dot crew. But
Okay.
you know, this would have just worked fine though, right? Because the ship still does exist. I'm just entering the ship before the ship is being assigned to me. Okay, so you know the order of operations still applies, right, at top to bottom.
So neither one of those is better. Or
No, I mean, yeah, they're both the same, I think.
So do copies of objects?
In fact, the only huh?
Do copies of objects equal each other?
Object references do, right? So if I were to say, hey, hey, good ship equals ship and better ship equals ship, good ship and better ship would equal each other because they're just both references. Like, I'm not actually creating a new ship, right? But if I were to what's called clone an object, even if they're exactly the same in every way, if I were to clone it, they wouldn't equal each other because they live in different areas of your memory. They're different objects. Okay, it's kind of like comparing two arrays. Remember, you can't say two arrays equal each other even though if they have the same exact things inside because they're oblivious to what they are or what's inside them.
So with the object references, if you said, you know, old ship equals blah and new ship equals blah, if you would change new ship to equal something else, would that also change old ship?
That's a great point. Yes, that's called a pass-by reference. Okay, and that's actually, I remember going really in deep when I was first learning this stuff, and it was so confusing to me, and it really became very natural later. But what you're saying is, let's see if we can make it happen. Let's say I said, let's say var a equals 1, 2, 3. Okay, var b equals a. Okay, so now a is 1, 2, 3. B is also 1, 2, 3. If I said b dot push 4, B now has 1, 2, 3, 4, but what does A have?
Never changed.
yeah.
It did change because it's a pass-by reference. A and B were never different. They were just there were two reference points that were pointing to the same exact array. The array lives in your memory somewhere, right? Your memory doesn't care. Where's the markers?
It's like the whole time there's only one array.
Yeah, there's only one array, right? Yeah.
Same with objects.
Same with objects, right? An object would live. Like when I say the word, does everyone understand when I say the word memory? I mean literally the memory stick in your computer. Okay. And every once in a while, I feel like since I've started programming, I notice them more. But surely I saw them before. But every once in a while, you'll get an error, and it's just like problem at 0x12, and it's like this really big ugly number, and that's like an address in your memory that became corrupted, or something just didn't happen right, or the electrons didn't quite process right and became corrupted, or just some reason. Sometimes your computer, I think Macs freeze a lot more and don't give you a thing. Windows will sometimes give you an error. Will tell you, hey, this memory address, something happened, it didn't work. Yeah, so if I say, if I have an array, this array lives in my memory, okay? And there's 2 points. If I just say off to the side, 1, let's make it totally different. 1, 9, 8, 7, 6. Okay, so here's an array. I said 9, 8, 7, 6. This existed for like an instance, and then went to go be garbage collected.
We didn't assign
Yeah, because we didn't need it. And your computer didn't think we needed it. We didn't assign any reference to it. And you might have heard me refer to things like you have to grab it or capture it,
Yeah.
right? And that's because if you don't do it, it will go to the garbage can and to be garbage collected.
So instead of saying A or B equals to A, if you were to say is equal to an array of 1, 2, 3, and then you were to push 4 on B,
Yeah.
then that only changed B?
No, it went to it went to what B was referencing, which is an actual thing, an array. Changed it. But A, so first what I did was I pointed A to this array. And said the pointer is going to keep it from going to the garbage.
Yeah.
Okay. And then what I did is I said, oh hey, well B equals A, which basically just goes straight to the same reference point. There's only one array.
Yeah.
Okay.
If you were to create a second array with B using the exact same stuff as A, like if you were to say B equals
Oh yeah, like right now at this point, right. So if I were to say B equals 1, 2, 3, 4, and now said B dot push 5, I've broken that reference, right? B is now referencing a whole new array, regardless of it looking exactly the same. So now B has 5, but A is still pointing to the old reference. And why it's also important that, so now if I lose A, I'll lose reference to that. It's gone. Okay.
I'm kind of confused. What if it's just a variable, like variable A is 5, for example, and then variable B is equal to A? If I change variable B,
Oh, if you're thinking about primitives don't really keep that reference. Okay, so let's see. Let's test that. I'm not sure how extensive my knowledge is of this. So A equals hello. Okay, and then B equals A. All right, and then I said B. I don't know. What do you do? To uppercase dot to no B. No, let's not do that. Hold on. Let's do numbers instead. Because I can't think about how to change a string, like affect a string. I can only bring in a new string that's changed, right? If I do to uppercase, it'll just give me a new string that's uppercase. That doesn't count. But let's do something like A equals 1, A equals, or B equals A, and then I said A plus plus. That should increase A, but B equals A. So if this past by reference thing is holding true in this circumstance, B should also have increased, right? So A is 2, and B is still 1. Okay? So the primitives, right, as they're sometimes called, things like strings, undefined, null, booleans, numbers, those things aren't objects. Those things are actually, if I say, that actually created a new thing. I can't think of the words. Do you understand what I'm trying to say?
So an array is not a primitive?
Yeah, an array is not a primitive. It's actually an object, right? Like we showed that last time. It's actually an object. Everything's objects except for primitives.
So arrays, objects, and functions.
Actually, and that's not even true in JavaScript. Actually, everything's an object, but it's like a lower level. It's like a different kind of object. Oh, that's hard, huh?
sorry, it's just
Really
confusing.
kind of said
Yeah, I know. It's hard. It was so hard. I remember grasping these, but sometimes this trivia helps you, and then sometimes it just, I haven't really thought about this in a long time. So A equals, if A equals 1, and then I said A equals B, or I said B equals A, actually what it does is it checks this and says, oh, that's this, second class citizen or something, whatever, and says, no, I'm not going to actually duplicate the area. I'm not going to duplicate that data, or I'm not going to point that data. I'm going to make a new one. So it kind of clones it, right?
What
Yeah.
makes sense.
So where that does that automatically, you have to actually specifically tell it to do with objects and arrays.
Yeah, objects and arrays are objects that don't clone like you think they do, right? Like now maybe the thing I was telling you about arrays, maybe that makes more sense than this, right? But we were depending on this the whole time to do a lot of the stuff we were doing,
Yeah.
right? And so now you just have to realize that arrays and objects are a different kind of class than the primitives that I'm talking about, like strings, numbers.
Do functions count in the special stuff, like without?
Yeah, they would be passed by reference, right? But then sometimes you do want to clone things, right? And that's the word I'm giving you now. It's called cloning, right? And there's also there's cloning and there's deep cloning also, which is I can't think of an instance where we have to dig into that. But that does solve problems sometimes. So, any questions about this so far? A pass by reference? Okay. It makes sense, I think, if it's explained correctly. So this will work. That's fine. That's fine. And it's giving us all this junk right here. So in this example, we're saying console log rick.ship.name. So rick.ship is Rick's the instance. The ship that it belongs to is this ship right here, and then the name of that ship is this first one. That makes sense. I pushed Rick into the mav crew, so 1 makes sense. Mav.crew, see, this looks really ugly. Mav.crew, first item in the crew, which right now is Rick.name. Rick.ship equals mav. Okay, that's a good point. That's a reference, right? They're both referencing the same object, so it's easy for me to say that that object equals that object, because references are literally talking about the same exact space in your memory, the same block. So that's not the same thing as saying these two ships are named the same thing, had the same type and the same ability. Those are different ships, right? That's two metal ships, and just by definition, they cannot be equal, right? Even in the real world, you cannot have two things that are inherently equal to each other, right? There's some difference. But if you're pointing to this, if you're both talking about the same thing, then obviously those are equal, right? And that's what's happening right here. That's why I'm able to do this. And then this is really just another way of sort of saying, this right here, just backwards, saying that the first item in that crew is Rick. All right, so I think here's the hard one. So let's look at this. Each crew member has a different job, so does the type of ship. Only a pilot can fly a MAV. Only a mechanic can use a repair ship. Commander is responsible for directing the main ship. An object with key value pairs is provided. So here's another word again, object, right? But it's like a different type of objects than what we're talking about. Right? Different in the way they're being used. They're not like different in the way JavaScript sees it. It's just, we're using this as more of like a key value pair, where we just have like a key and a value, key value, key value. There's no instances of this going to be made. Okay. In other languages, these are so different that it's really two different types of objects. Okay. JavaScript just kind of like mushes it together, which sucks because you have to always see the word object so many times. But this is an object, also known as an associative array, a list, or a hash. Or a hash map.
So for this type of object, is the first thing in it like pilot? Is that counted as a string?
Pilot is a key. Okay. It is always considered a string though. If that makes you feel better.
Okay. In terms of like seeing if it's equal to something else, like if that was 0 and you were trying to see if it was like deep equals a string 0, it would come back true.
There's a way you can get a collection of the keys, but I don't think it works kind of the way you're talking about. A key is the reference of where in memory that lives.
Okay.
And then the value is the value that lives in that spot. Okay. We kind of said it before that job types would be like the city, and this would be, job types would be the street that you're on. This would be the address of like your home address, the number address, right? And then this would be the actual house that lives there.
The values don't have to be strings.
The values don't, values can be anything. Literally anything.
So, from like videos or whatever that I saw, it was like objects were referring to that thing, the job types, and then constructor objects were referring to the other one that we were just using, the instances.
Yes. I hope. Yeah. And in the context I think I'm talking about, I think that's what they're referring to. I think sometimes I've seen it like object. This is an object literal. Manny may know more where I'm at. This is an object literal, and this is a constructor. Yeah.
Yeah, I think that's correct.
Yeah.
And there's the constructor function as a method of the class.
Get out of here, man.
Which is which is basically the new keyword. Yeah. Constructor function would be the factory that creates new instances based on the class. Most of the time it's new. Actually, it's new in I think all 4 languages that I usually program in.
So you create a constructor, what do you do when you're talking about the
Yeah. Yeah, building it like this, you get kind of a built-in constructor with it using the new keyword. No, I think in Python it's different. I don't remember though. We'll do it later. Pilot, mav, mechanic, blah, blah, blah. Okay. In ship class, write a method mission statement, ship class, mission statement. Okay. You know, and also notice sometimes I will try to follow it I'll try to follow the instructions literally at first before trying to understand the entire thing of what I'm supposed to do. Try to boil down and try to do what it's telling you. In the ship class, write a method mission statement. And maybe then look away, right? Go write that part. That part's easy, right? We know how to do that. Don't get bogged down in that stuff. You know, that's the first part. This method will return can't perform a mission yet if none of the ship's crew has the correct job that matches the ship type. And it will return the ship's ability if there is a crew member that does have the correct job that matches the ship type. Okay, so if, well, first of all, someone in the ship has to have this job, right? Which is insinuating that what?
There is someone.
There is somebody, right? So that's going to be the first gotcha. You're going to have to say this.crew. You're going to have to make sure someone's on board. So this.crew.length is greater than 0. And that someone has the right job. So and.
Can we say just bang and then this.crew.name?
Yeah, like it gets rid of an entire case of if there's nobody, then nothing can happen.
That's a good point. We'll refactor. Let's refactor. That's a good point. Let's see.
No one, like, if there's no crew members, then it can't do anything, so it'll return that like can't perform a mission yet.
Okay. Let's write it. If this.ship.correct job has the match, and it will return the ship's ability. If there is a crew member that has the correct job that matches the ship type. Okay, let's write this as if there's only one person. Okay, which will be everyone on the ship. If there's only one person, we just have to ask the first person, and we technically asked everybody on the ship. Let's do that first. We'll say this.crew. Okay, if he's the first person on the ship, he should be at what index of the crew? 0. And how do I ask him his job type? .job. Okay, so that should give me either pilot, mechanic, commander, or programmer. Okay, we see those jobs are mapped to the correct type of ship, right? Which conveniently matches the types that I'm passing in here to ship, right? So I need the job, but I don't need the job because the job's going to return, for instance, pilot. Pilot's not going to equal the type, right? But if I look in the context of this hash map here, this object here, how can I squeeze mav out if I only have pilot? Right, so I can look inside the context of job types. I can refer to that object, to that hash map. I can say, okay, job types, and then look at the key. Does that make sense?
Yeah.
Because I want this to be a key, because that key maps to the value that I'm looking for.
Does your heart skip a beat every time your phone makes noise?
Well, yeah, I mean it's like text messaging, you know. So I'm like, I was just not gonna text message me. Maybe she will. I don't know. So if it's like ringing, then I'll freak out probably more.
Going into labor, LOL.
Yeah, or just like baby emoticon or whatever emoji. So job types and this dot crew. So now that it's inside of hard brackets, it becomes a key, right? The key being the pilot, job types being the object, and so that should return to me the value right here, mav. And this, we're just guessing what type of ship it is. That needs to equal, and so what part of the ship should also be mav? The type, the second thing, the type. So if this equals this dot type, then I should return, what is it? Not the right job or something.
This dot ability.
Oh yeah, this one should return this dot ability. This dot ability. Else, return.
It's string.
Yeah, what is it?
It's
Can't perform mission yet. Has to be double quotes because there's an apostrophe in there. Or you can escape it or whatever. So this looks okay. Let's run it. So we have Mav, we have Luke entered the ship. Oh yeah. I guess I better enter this stuff. So by Luke. So Rick.enter ship. And then we should be able to say mission statement, mav console.log mav.mission statement. I'm going to run it. Ascend into low orbit. So that actually worked, right? Okay. So let's call this before Rick goes in. So I'm calling this before Rick goes in. So we have an empty ship at this point, right? And I get this really cryptic error. Job types this dot crew 0 dot job equals this dot type. So what's happening here?
There's no crew.
There's no crew 0, right? So there's no, so I can't call dot job on undefined, which is now actually exactly what it says. Can't read job of undefined. And so this is back to our point we were at. We were saying, okay, we have to make sure that there's someone at 0 index, right?
Does it have to be 0 index or is it like multiple?
What if there's multiple people? That's another thing too.
You would just do a for loop, wouldn't you? Instead of the 0, you'd use like the I.
Do for loop. But what about all those other cool functions we just had a whole day on? What could we use out of those?
What is it?
Kind of do for each. What is it? What's a good way for us to like? I want to say the word to like pinpoint the person. Filter, but if I'm just looking for, but do I need like a group of people to all match? No, I just need a single one. So what's like the filter version, but just for a single one?
Has property does.
Actually, some would actually be pretty good.
Yes,
I was thinking of find, but actually some is actually a better answer. Because some's going to say, hey, at least some people on this ship, at least one person has what I need, and that'll just return true, and that's actually pretty solid right there, right? I was thinking you'd use find, but yeah. So some. Okay, so I can come up here and I can say, okay, so instead of this.
Can I ask a question about that part real quick?
Yeah.
Is just the use of the brackets, like, is that to indicate like the keys? Is that what that means there? Because I got real hung up on that, how you have this dot crew, the whole thing in brackets, and then the index in brackets.
Yeah, so you have to see this as two different things, right? So to access a value on an object like this, or an object literal like this, you do the name of the object and in brackets pass in the key, right? So first I'm calculating the key. First it calculates the inside, right? JavaScript calculates inside then outside, right? Same thing as algebra, I think, right? Order of operations, whatever. Arithmetic, that would be. It'd be the inside, then it moves outwards. So first it says this.crew0.job. If the first person's Rick, his job is pilot, so that would return pilot. And then it would take that key into job types and return mav right here.
That's where I couldn't figure how to pull trying
Yeah.
everything. I just couldn't get that part.
Yeah, and this is why I don't like dots, because dots don't always work, right? But for some reason, JavaScript, you're supposed to use them when you can, which is, I think, not a good practice.
So why wouldn't this dot crew dot job work?
Well, this would work where here. This works fine right here. I'm saying you could also do this, and I think it'd be better practice to do something like this. I think it's better practice, but it's officially not on most linters. But what I'm saying is, you have to use a bracket, like for instance right here, because like where's your key?
You're not in the key unless you have
Yeah,
it. Yeah.
exactly. So to pass in a dynamic key, I have to make sure to always use brackets, right? Because I need to configure what's inside the brackets.
See, I knew why that wouldn't work, but I
Yeah,
didn't know there was
but like why? Yeah, like so how would I do that, right? And you do it with brackets. So this is a case where you have to use brackets. No way around it. Yeah, so let's use the sum method. So we'll say if this dot crew. Oh, and then I get the answer to this one would be first check. Well, the initial one would be this dot crew dot length is more than 0, and the first thing would match. That would work, but then we hit the problem. What if it's not the first person? What if it's the second person, right? So then we realize we're gonna have to do some sort of loop probably eventually. So what we want to do is we want to use the sum method to say, hey, at least somebody on this ship. Because if there's no people, that also some will be like, okay, I just won't run it all and say false. Yeah. So if this this dot crew dot sum. Now, what am I going to name each person inside the crew?
Person.
We can say person. Say I probably just would say like lowercase crew member, because that would give me a hint that it's a crew member instance, right? Because crew member is the class name that we're dealing with right here. Crew member. Sometimes I'll put extra spaces if I'm stacking up. Kind of helps separate it. Okay, this dot crew member. So this is just, instead of me writing it on multiple lines, I'm just going to write it across. Crew member equals return. Return if that specific crew member, if his or her, what? Hers or her job, but the job's going to be, still going to come up as pilot. So I need to still wrap this in a job types, because I need to look up his or her job. If that equals this dot type.
I have a question.
That should work.
I thought the fat arrow took care of the return.
No. And no, you would have to return something in here. Fat arrow, this is a good example of why we use fat arrow and what we had to do before. So let's take this out of here. This looks ugly anyway. Way too long. Way too long. So there's my if statement. I'm just going to put this beforehand. I'm just going to say, I usually just put a variable like const found, right, equals okay, is everyone okay with this right now? So found should be either true or false. Right? It'll be true if one of the crew member jobs is a key. If the crew member job, which is a key, matches the value of the type of ship it is, then return true. So if I have 100 crew members and the first guy or the second guy matches, I don't have to go through all 50, right? It's just going to say, hey, someone's right, I'm going to return true. Do I remember writing that? Remember implementing it for our homework? Yeah. So now we actually get to use the nice side of it. Everyone okay with this right now?
How are you using the word sum there? I mean, is that just a
Sum is just,
method?
it's a method on an array
Okay.
that says, hey, do any of these pass this test? That's what sum means. And actually, other languages, you can also say any. Any is like the other thing, any. sum. Okay. And then I would say if found, then return this ability, else return that. So this would actually pass our test. This is what we're looking for.
Alright, can you walk through
The,
the function?
this.crew.sum.
Yeah, what is the passing in?
So this dot crew is an array, right? Arrays have these higher order functions that we implement. One of them is called sum. And when I call sum, the first thing that I get access to is the element itself inside the array. So it's just up to me to name each thing. What am I going to name each item inside this array? The array is a list of crew members. So I'm going to call each item just a singular crew member.
That's another
Yeah.
instance where you can know whatever.
Yeah. Sometimes it's weird to know when you can and can't do that. But honestly, you actually always can and can't do that. So really in your mind, just always know that's what's going on. Now, what if I didn't know? What if I didn't know how sum worked? Where would I go?
MDN.
MDN. Just go look at the MDN docs. Let's go look at it. Let's see if we can confirm what we're talking about. Oh, MDM sum. There we go. So it looks like you get access to the element itself, which this time we're calling crew member. You get access to the index at which what loop you're on. It'll give you the index of that crew member. If it's the first person or the second person, it'll give you like 0 or 1. And then you get access to the array again, which is sometimes useful because maybe you need to manipulate the array on the fly for some reason. Seems like a bad idea, but whatever. Sometimes we'll need it. Everyone okay with that? But this time we're only using the first thing. And instead of element, which is kind of like a general sort of broad, doesn't really explain much what it is, we're going to say crew member. Because I get to choose that name. These are also just descriptive of what they are, right? They chose those names. It's the reference, it's the reference, it's what it's referencing in your memory that's important. The first part references the item where it lives in your memory. The second part references the index of the array that it's in inside the memory. The third part is referencing the array itself. All right. Again, we're getting really deep. We don't have to think about that hard if it's hurting your brains.
I have just a little quick question.
Yeah.
Like, it's not really terribly important, but could you just use on return this ability? Could you not just return ability since the ability is being brought up at the beginning of the whole process?
This right here?
Yeah, just taking away this, would that not work?
Well, ability is a local variable, and that hasn't been defined anywhere, right? Because
Isn't it defined whenever you start the whole process? Right? When
Oh.
you put in ship, name,
No, because
ability?
these are only run on instantiation. This is part of the constructor function that we were talking about.
That's why a capture would.
Yeah, which is exactly why we have to do this. Why you have to put that there. Otherwise, these would be lost. The new function takes those arguments and gives you one chance to capture them on construction, on instantiation.
That's why they call it construct.
Yeah. All right, so we're here now. Now I want to demonstrate why fat arrow was such like a big win for JavaScript. Because before, we had to write this. So now we're inside this new function, okay? And actually, this sort of works the same way, right? The fat arrow is really just eliminating your need of writing the word function, but it does one other thing. It passes in context. Because this function doesn't get the same treatment that this one just happens to get. This one gets kind of like you can kind of think of it as your your instance context being passed in like one level deep. You can kind of think of it right here. But anything inside that function, if you make another function like this, you get a brand new context. This right here has no idea of the instance.
So only with fat arrows can you use this within the...
Right. Fat arrow smooths passes your context in. That's really like the only real thing I can think of that it really does.
It's the same this if you use the fat arrow.
Yeah, and honestly, there's not really very many opportunities where you don't use the fat arrow. Now, almost everything you do should be fat arrow, right? Unless you define it like this. But even some people have gotten away from that and just assigned all your functions to a variable, and then you can use the fat arrow. But you don't need to. So usually if it's a high level function like this, like if it's just like all the way pressed to the left, I'll say the word function because I don't care about context because it's the global context anyway if I don't want it. But after that, always fat arrow. So people do always fat arrow. The only thing that doesn't ever use fat arrow is jQuery. Because you remember in jQuery, you use the word this a lot because it's like the thing that you targeted. Okay, so that's why jQuery right now is kind of at odds with ES6 people because it just doesn't really jive that well. Anyway, so for those of you that don't understand what's going on, let's try to run this. Found. I hope this doesn't work. Let's see.
You're gonna return this ability. Like
Oh yeah. But it's still not. Oh, so I'm getting can't perform a mission yet. Well, yeah, because it's still up here, huh? Let me. There we go. Can't read property type of undefined. Okay? We'll get really, you know, these won't look scary forever. But this is actually pretty descriptive. I'm trying to call type. I want to stay on the computer so it gets recorded. I can't call property type. Calling a property. The way I call property is dot property name, right? I'm saying this dot type. I'm trying to call this dot type of undefined. This is insinuating that this is undefined, right? But if I made this a fat arrow, and ran it again, it works just fine. Because I'm passing in this. This is no longer undefined. It passes in that context of this, okay? So what we used to have to do is pass in our context, okay? Most popular way that I can think of is you use the word that equals this. Okay, you define a whole new variable. Okay, that's not a special name, not a special variable name, it's just a common one. You say var that equals this, and inside here, you revert to that.
Because it hadn't been changed yet before.
Yeah, yeah, I just captured this context, because it's just a reference, I'm just pointing to it, right?
Just like you did with
Yeah,
the-
exactly, I just set a new reference to the context, and then I'm referring to that context inside there.
It holding me up because it kept giving me undefined, and I could
Yeah.
not figure out why it wasn't carrying over.
Yeah, okay.
Could you pass this in under mission statement function? Could you pass this to
Inside of there?
function crew member? So it'd be function this and crew member? Never mind, I'm trying to get too complicated.
Yeah, the things these are designed. These are really designed after something called underscore. Well, which underscore is designed after normal things other languages had, but underscore used to be what everyone had to bring in those kind of functions. The higher order functions before JavaScript really had them, or these nice ones. They used to give you an opportunity to actually pass in the context as the third argument. And so even then we couldn't get around it. You had to like manually pass it in. So underscore had like this extra feature where you could pass it in.
You could do like blah blah, comma blah blah, comma this.
Yeah, like you would write like this. Like that. And then this would work. For underscore. Doesn't work like that with the native JavaScript. And it's funny, I keep saying old days. This is really like 6 months ago. But, you know, it's not, you know, this is new stuff. And I'm sure in Campus Manager, I bet you'll see it everywhere because I just haven't updated everything yet. Anyway, but fat arrow functions, definitely a way to go. Use them all the time. It's good practice. You don't have to worry about this. You know, it's not like this in other languages, so it's not like you're missing out on anything. It's just like a JavaScript quirk that we used to have to work around. Now we don't have to work around it anymore. All right, that's good. That's the end of this lesson. I want to move on. Any questions about this? Let's make sure it passes. npm run test. Yeah, we're good. All right, checkers. Oh man, 7:35. Nope. Okay, most of checkers, not most of it, but the board's already done out for you, right? So if you run it, oh, it's blank. So you have to build the checkers. But the board you see is kind of like a grid, kind of like how tic-tac-toe was. And if you, when you build your checkers, oh man, I think I had some extra information in the app guide. Let's go look at it.
Manny, is this what you did looking at board for Battleship?
No.
Oh.
There's like a one-line thing you can do with that ray. So, and then you can paste it.
That's cool.
No. There, I'll just put this on there for now. This is what it should look like. It's pretty cool. Point 1, 6. Book messed up. Let's see. I'll go ahead and keep this up here until it launches. It's the idea of who knows what, right? And in our past examples, it was really easy who knew what, right? Like it's easy in Star Wars to know that a person worries about person things and your ship worries about ship things, or the same thing with the Mars thing. But this one maybe is not so good. So, for instance, a board, a game, and a checker, who knows the rules of the game? I would think the game would probably know the rules, right? So game probably know the rules. What about the location of a checker? The board?
And the game.
See, that's actually a question that could actually go either way, right? Do the boards keep track of where on it the checkers are? Or do the checkers actually just know where they are? As long as they're following the rules. If you do a check with the rules and they match, maybe I can just give the checker its coordinates and then the board asks the checker where to put it and puts it there, right? Which I think is maybe a better way here. So maybe the checker just has like a location attribute. No, maybe not. Where did I do this? This side greatest checkers. No, I think it's farther down when we talk about the location. Let's see. Oh no, I take it back. So in this one, the board actually keeps track of where the checkers are. So you have a visual board, which just your script has, but your board looks like it has a grid of where these things should go. And you're just taking things out of one grid. And think about a board. Remember, it's just like the same thing as tic-tac-toe board, right? But instead of an array of 3 arrays, you have one array of 6 arrays, right? With 6 items each or something, whatever makes up a board. Oh, here it is right here. This is what your board would look like. And your job is just moving from one to another. You just check to make sure your coordinates are legal moves. Maybe, or something like that. You may not even have to check. This dot create grid, this dot. So in here, our concern is the board knows where the checkers are. Checker seems to only really know what type of symbol it is. All right, and I give you how to make little symbols right here, or the first one. You can use this string dot from character code and then type in the Unicode right here. And if you use the white one, this is a white checker. So just assign this dot team or whatever, this dot symbol to this, or this dot symbol to this, depending on what type of checker you are, right? Now there's only one type of checker class. That checker can teeter-totter on a white or a black, depending on how it's created, right? So how would I write that out? How would I instantiate a checker class, or how would I write that checker class out? If I went to function checker, upon instantiation, I need to set this instance variable. So where would I put that? This dot symbol equals. Well, would a checker ever be null though? I would never have like a null checker.
Yeah.
So you
Right.
have like one or the other.
Right. So I would want to pass that into the constructor.
0 or
And
Right.
what is symbol?
Symbol is either you can say the word white and black, and then have like a if symbol equals white, then set it equal to this dot symbol needs to be that character code. String dot character code dot for white, else do the other one. Okay, or you can just pass. I guess you could technically pass those in if you wanted. That may be weird. So I'll probably do it like this. So maybe instead of passing in the word symbol, call it color. And say if color equals this, then this dot symbol equals one of those string things that I gave you. Otherwise, make it the other one. All right. So try to see how far we can get in class with this. You'll have all weekend for this too. Let's build out this checker part together. Let's build a checker. Let's pass in a color and say if color equals white, then this dot symbol equals, and then I gave you here the character code for a white checker right here. This is messing me up. Else, this dot symbol equals the other one. So what that means is out here I should be able to say const white checker equals new checker item white const black checker, or any other color checker for that matter, equals new, same checker class, but this time pass in anything except white. And now I want to console.log console.log white checker and a black checker. And now when I run this, hopefully at the top, oh, at the top I'm getting just the symbol, but you see the symbols like this? Symbol is open circle and closed circle. In fact, what I should be console logging out is not the checker itself, but the symbol for that. Oops. There you go. There's a white checker right here. Can y'all see it?
Yeah.
There's a white checker, there's a black checker. Okay. So this just goes to show you, now you know you built the API for a checker. You instantiate a checker with the color, either white or not white, anything except white. And then the API for a checker is you could say that dot symbol, and that gives you that symbol, right? So now, down here, let's analyze this. I create a grid right here, and I show you what that looks like right here. Well, first, grid is empty, right? And then when I call create grid, it fills in my grid. And now when I view my grid, I'm viewing my grid looks like this. It's just empty. But you can see here that either I push in if this dot grid row column. So what I'm doing is I'm checking that particular place in my grid, right? I'm saying, oh, that's right. That's why I did this. Right here, I'm saying if this dot grid row column, so I'm digging into my grid here, and maybe this is my row column right here, this one. I'm saying, hey, if instead of null, which returns falsy, if it is falsy, I just put an empty space in there, right? Which is why they're all empty, because they're all nulls. But if I were to instantiate a checker and stick a checker here instead, it should render the symbol for that checker. Then push this dot grid row column dot symbol. So if instead of null there's a checker, I can push the symbol in there instead. And so the idea is that I generate all these checkers. I generate a checker. I say checker.new, or I say new checker 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 24 times, half of them with white, half of them with black, and I stick them in this row, this column in my grid. I should render this automatically. All I want to do is render 24 checkers, and I want to put them, my white ones here, 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 you know, here, 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 whatever. Stick each of those checker instances at each of these coordinates, and this should automatically work for me, this part. All right, so in theory, so let's do one manually. Let's do one by hand, and maybe that'll give us a push in the direction of automation. So we see right here that I have two checkers available to me, right? So let's dig in somewhere. I'm already creating the grid, view grid. So let's, I'm going to move this down into my game logic, right? We don't want to do this. We don't want to actually stick this stuff out in the open like that. I'm going to stick it down in my game logic. this dot board, this dot create grid. Let's say white checker. So I have a white checker and a black checker, and I can say this dot board. Okay, board's the class. The board has a grid of where it's keeping all these things. Dot grid. Let's say I want to stick my white checker at this first location right here. Dot grid 0, 1 equals white checker. Whoops. Yeah, equals white checker. This dot board dot grid and the first black location 5, 0 equals black checker.
Why would you put that in game versus?
You actually wouldn't. It'd probably make more sense to put it up in board.
Yeah.
But the logic stays the same. I think actually they want you to put it in a, we can follow this. Create checkers. So there's a create checkers. Okay, now create a method called this.createCheckers. So inside my board, I have view grid. Okay. So this dot create checkers equals function. You actually don't need semicolons after that. I'm going to instantiate a single white checker. I'm going to instantiate a single white checker and a single black checker, and then I'm going to place that white checker at the first location here. I'm going to place the second, my black checker at the first location of the black checker. And I'm going to make sure that after I create the grid, I call this dot board dot create checkers. And now when I run this, let's see what happens. Cannot read property grid of undefined. Oh, I'm sorry, because I moved it up here. It's this dot grid, because I'm inside the board. I don't need to refer to the board here. There. Got 2 checkers.
What did you instantiate to call that? This dot board dot create checkers. What was it?
Right here. This dot. I'm just calling this function on the board.
And then when you say like instantiate, you're talking about const white checker equals new checker white.
Yes. I'm instantiating 2 checkers right here with a new keyword.
And do you have to instantiate those inside of the create checkers function?
Yeah, I think that's what I'm testing for, and it says right here. This dot checkers will be your empty your repository for your checkers. This dot checkers, I think that's already in there. Nope, it's not. This dot grid. So actually, it wants you to create this dot checkers like that, and then this dot create checkers wants you to push in all your checkers and then assign them to wherever. So that's kind of what you have to, that's what I'm testing here. Now, I did this by hand. You're not going to do this 24 times, right? The idea is to generate all 24 checkers, half for black, half for white, put them in the appropriate places, put them in the appropriate places, do I use this dot checkers anywhere? No. And then keep track of all your checkers. Now, why would I want to keep track of why would I want to keep all my checkers in a list? Like think about me killing checkers. So if I kill a checker, I remove it not only from the board but from my list of checkers. Why would I?
If you won.
Because, yeah, to see if I won. Because then I could always just run a function like sum. Hey, are some of these white or some of these black? Or are all of these white or are all of these black? Because then that's how you tell if someone won or not, right?
On here, what is like under const black checker equals new checker black?
Yeah.
This grid 0, 1 black checker. What is that doing right there?
That's putting the single white checker on my grid.
Okay.
On my grid at this first location.
That's underneath the function board.
Yeah, that's a method on board. All right, we can shrink these up. There we go.
Did you, maybe I was just a little bit behind, did you create another const white checker or were you copying and pasting it?
I moved it to where it was ultimately supposed to go. It'll ultimately go in there. Most of the work I think is actually done in create checker. Well, for the first step anyway, of creating all your checkers and putting them on the board, all is inside here. Yeah. So I'm gonna have to create some sort of loop to loop over to instantiate 24 checkers, half are white, half are black. I'm gonna have to put them in the correct location in my grid, just like I did here. 0, 1, 0, 1. Notice the formats are a little different, so you're gonna have to account for that. And then you also need to collect these inside of checkers, because that's how you keep score.